This is the same model, answering the same question on the same day. The only thing that changed between these two numbers is which one they let you see. For years, a benchmark score was the closest thing AI had to a report card. 99% meant 99%, full stop, no questions asked. Every new model launch came with the same ritual. A chart, a green bar climbing past the last one, proof supposedly that the machine had gotten smarter. Then, on February 23, 2026, something happened that had never happened before in this industry. OpenAI, the company that helped make one particular test famous, publicly walked away from it. The test was called SWE Bench Verified. Not because the test got harder, because it turned out the models had already seen the answers. Imagine a student who aces every exam because a friend on the faculty keeps leaving copies of the answer key in the library. That's roughly what had been happening at scale for years. MMLU test questions turned up, word for word, buried inside the same web data scraped to train the models later tested on them. Human evals coding problems. A striking number were near duplicates of solutions already posted, years earlier, on sites like LeetCode. And some of SWE Bench's own bug fixes were sitting inside the very code repositories the model had already trained on. A model doesn't need to reason its way to a correct answer if it already memorized one. When OpenAI actually audited this, frontier models from multiple labs reproduced the exact original bug fixes, including specific details the test question never even mentioned. There's a name for optimizing toward the test instead of the real target now. The industry calls it benchmaxing. It's an old rule finally catching up with AI. When a measure becomes a target, it stops being a good measure. Once one single benchmark started deciding funding, headlines, and bragging rights, research quietly stopped chasing better reasoning and started chasing that one specific score instead. It's a pattern that shows up anywhere a number becomes the whole point, instead of a rough signal for the thing you actually care about. Teams actually running these systems in production found something the leaderboards had never shown them: a 37% gap between the lab score and the real-world result. And for roughly the same accuracy on a real task, two different benchmark leading systems could cost 50 times apart to actually run. Which means the number on the leaderboard was never answering the one question that actually mattered: will this work on my problem at my cost? Not whether it can somewhere under lab conditions, whether it will on the thing you're actually trying to build. The lab number was never lying about the test. It was just never, honestly, about your test. So what do you actually do with a benchmark score in 2026, now that you know this? Treat it as a flaw, not a verdict. It proves a model can do something under lab conditions, never that it will under yours. Ask which version of the test it was scored on, and whether that version is even public anymore. Then run your own 5 real examples from your own actual work before you trust anybody else's 99%. If you're choosing a coding assistant, don't ask which one wins on a public leaderboard. Feed it the exact bug you're stuck on right now today and watch what actually happens. The only benchmark that's never been gamed is the one you build yourself, on the task you actually care about. The number that matters was never the one built to impress you. It's the one that doesn't move, even after someone finally checks it. Next time a leaderboard says a model is smarter than it's ever been, ask 2 questions before you believe it. What was it actually tested on, and who exactly was grading? 99% was never the lie. Trusting it without asking either question, that was.